Notching floor joists to accommodate electrical wires is sometimes necessary, but not generally recommended and requires careful consideration. There are some factors to consider and steps to follow. Firstly, consider the structural integrity. Notching weakens the joists, especially if they are already undersized for the span they support. Notching should only be done on the top or bottom edge of the joist, never the sides. The notch should be no more than 1/6 of the joist height and 1/4 of the joist depth. Secondly, consider electrical safety. The wires should be protected from damage caused by flexing or pinching. The steel plates over the notches should be large enough to prevent the wires from contacting the edges of the notch. Ensure that the wires are not overloaded and that the insulation is not damaged. Thirdly, consider building codes. Many building codes prohibit notching joists unless specific criteria are met. Consult with a licensed electrician and a structural engineer to ensure compliance. Here are some steps to follow. 1. Assess the need. Determine if notching is the only viable option for routing the wires. Consider alternative solutions such as drilling holes or running wires along an exterior wall. 2. Verify structural capacity. Consult with a structural engineer to determine if the existing joists can support the added load and notching. 3. Plan the notch. Mark the location and size of the notch on the new joists, ensuring it meets the minimum requirements. 4. Cut the notch. Use a saw to carefully cut the notch. 5. Install the wires. Lay the wires in the notch and secure them using staples or wire holders. 6. Protect the wires. Cover the notch with steel plates large enough to prevent contact between the wires and the edges of the joist. In conclusion, while notching floor joists for electrical wires is sometimes unavoidable, it requires expert assessment and careful execution. It is essential to consult with qualified professionals to ensure structural integrity, electrical safety, and compliance with building codes. If significant rewiring is necessary, it should be included in the renovation costs. It is worth noting several points regarding electrical wiring and safety. Firstly, conductors must be protected. According to the National Electrical Code, specifically NEC Section 300.4, A1, cables and raceways installed parallel to framing members such as joists, rafters, or studs must be protected where they are less than 1 and 1/4 inches from the nearest edge of the framing member. This protection can be provided by steel plates or sleeves. This is because nails or screws could penetrate the wiring if it's too close to the edge. Secondly, regarding the notching and boring of wood joists, rafters and studs. NEC Section 300.4 D addresses this. Notches in solid wood joists, rafters, and studs must not be deeper than 1/6 of the depth of the member. Holes bored in these members must not be closer than 2 inches to the nearest edge of the member, unless otherwise permitted, and when notching or boring, structural integrity must be considered. When running cables through holes in framing members, ensure the holes are properly sized. The NEC doesn't specify an exact diameter, but the hole should be large enough to allow the cable to pass through without stressing the cable or its insulation. The hole should be neatly drilled to avoid sharp edges that could damage the cable. Fifthly, if the existing wiring is old or damaged, consider replacing it. Old wiring may have brittle or cracked insulation, which poses a significant safety hazard. Replacing it during the renovation can prevent future problems. Sixthly, ensure all electrical work complies with local building codes and is performed by a qualified electrician. This is especially critical in renovations, as older homes may not meet current safety standards. Seventhly, when securing cables, use appropriate staples or cable ties. Staples should be installed in such a way that they do not damage the cable insulation. Do not over-tighten cable ties, as this can also damage the cable. Eighthly, before starting any electrical work, always de-energize the circuit at the breaker panel. Use a voltage tester to confirm that the power is off before touching any wires. Ninthly, any junction boxes must remain accessible. Do not bury junction boxes behind drywall or other finishes. If a junction box needs to be relocated, it must be done by a qualified electrician and comply with NEC requirements. Tenthly, when adding new circuits, ensure the existing electrical panel has sufficient capacity. If the panel is already full or close to capacity, you may need to upgrade the panel to accommodate the new circuits. 11thly, use the correct type of cable for the application. For example, non-metallic sheathed cable, commonly known as Romex, is suitable for dry, interior locations. If the wiring is exposed to moisture or located outdoors, use a cable type that is rated for wet locations. 12thly, properly ground all electrical boxes and equipment. Grounding provides a path for fault current to return to the source, helping to prevent electrical shock hazards. 13thly, ensure that all wiring is properly sized for the intended load. Using undersized wiring can cause overheating and potentially lead to a fire. Consult the NEC or qualified electrician to determine the appropriate wire size for each circuit. 14thly, use appropriate connectors for making wire connections. Wire connectors, such as wire nuts or pushing connectors, must be listed for the application and sized correctly for the number and size of the wires being connected. 15thly, consider the impact of the renovation on other electrical systems in the house. For example, adding a new closet may require relocating or modifying existing lighting or outlets. 16thly, always obtain the necessary permits before starting any electrical work. Permits ensure that the work is inspected by a qualified electrical inspector and complies with local building codes. 17thly, ensure the smoke detectors and carbon monoxide detectors are properly installed and functioning. Renovations can sometimes disrupt these safety devices, so it's important to check them after the work is completed. 18thly, document all electrical work that is performed. Keep a record of any new circuits, wiring changes, and equipment installations. This information can be helpful for future maintenance or renovations. 19thly, consider energy efficiency when selecting new lighting and appliances. Use energy-efficient LED lighting and appliances that are ENERGY STAR certified to reduce energy consumption and lower utility bills. 20thly, ensure that all electrical work is neat and professional. Wires should be neatly bundled and secured, and all connections should be clean and tight. A professional installation will not only look better, but will also be safer and more reliable. 21stly, never attempt electrical work if you are not qualified or comfortable doing so. Electrical work can be dangerous and should only be performed by qualified professionals. 22ndly, be aware of the potential for hidden hazards when working in an older home. Asbestos, lead paint, and other hazardous materials may be present, so take appropriate precautions. 23rdly, when drilling or cutting into walls or ceilings, be careful not to damage existing wiring or plumbing. Use a stud finder to locate framing members and avoid drilling or cutting into areas where wiring or plumbing may be present. 24thly, use ground fault circuit interrupters or GFCIs in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor locations. GFCIs are designed to quickly disconnect power in the event of a ground fault, helping to prevent electrical shock injuries. 25thly, consider the use of arc fault circuit interrupters or SIs to protect against electrical fires. SIs are designed to detect arc faults, which are a common cause of electrical fires, and quickly disconnect power to the circuit. 26thly, when working with electrical tools, always use appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. This will help to protect you from electrical shock and other injuries. 27thly, be aware of the potential for electromagnetic fields or EMF when working with electrical equipment. While the health effects of EMF are not fully understood, it is generally recommended to minimize exposure by maintaining a safe distance from electrical equipment and avoiding prolonged exposure. 28thly, consider the use of surge protectors to protect electronic equipment from power surges. Power surges can damage sensitive electronic equipment such as computers, televisions, and stereos, so it is important to protect them with surge protectors. 29thly, ensure that all electrical equipment is properly maintained and inspected regularly. This includes checking for loose connections, damaged wiring, and other potential hazards. 30thly, if you are planning to install a new electrical panel, be sure to consult with a qualified electrician to determine the appropriate size and capacity for your needs. An undersized panel may not be able to handle the electrical load of your home, while an oversized panel may be unnecessarily expensive. 31stly, when running new wiring, consider the future needs of your home. It may be wise to install extra circuits or larger capacity wiring to accommodate future electrical loads, such as new appliances or equipment. 32ndly, ensure that all electrical work complies with the Americans with Disabilities Act or ADA requirements, if applicable. This may include installing outlets and switches at accessible heights and providing adequate lighting for people with disabilities. 33rdly, consider the use of smart home technology to control lighting, appliances, and other electrical devices. Smart home technology can provide convenience, energy savings, and enhanced security. 34thly, if you are planning to install a backup generator, be sure to consult with a qualified electrician to ensure that it is properly installed and connected to your electrical system. A backup generator can provide power during a power outage, but it must be installed correctly to avoid safety hazards. 35thly, ensure that all electrical work is properly labeled. This includes labeling circuit breakers, outlets, and switches so that they can be easily identified. Proper labeling can help to prevent confusion and make it easier to troubleshoot electrical problems. 36thly, consider the use of tamper-resistant receptacles or TRR, especially in homes with young children. TRR are designed to prevent children from inserting objects into the receptacle, which can help to prevent electrical shock injuries. 37thly, if you are planning to install a new electric vehicle charging station, be sure to consult with a qualified electrician to ensure that it is properly installed and connected to your electrical system. Electric vehicle charging stations require a dedicated circuit and may require upgrading your electrical panel. 38thly, consider the use of arc fault circuit interrupter protection for all branch circuits supplying 120 volt single phase 15 and 20 ampere outlets installed in dwelling units as required by the NEC. 39thly, ensure that all outdoor electrical equipment is rated for wet locations. This includes outlets, switches, and lighting fixtures. Wet-rated equipment is designed to withstand exposure to rain, snow, and other weather conditions. 40thly, consider the use of lighting controls to reduce energy consumption. Lighting controls can include dimmers, occupancy sensors, and daylight sensors. These controls can help to reduce energy consumption by automatically adjusting lighting levels based on occupancy and daylight availability. 41stly, ensure that all electrical work is properly inspected and approved by a qualified electrical inspector. An electrical inspection can help to identify potential safety hazards and ensure that the work complies with local building codes. 42ndly, consider the use of surge protection devices at the service entrance to protect your entire home from power surges. These devices can help to protect your electrical system and appliances from damage caused by lightning strikes and other power surges. 43rdly, ensure that all electrical equipment is properly grounded. Grounding provides a path for fault current to return to the source, helping to prevent electrical shock hazards. The grounding system should be inspected regularly to ensure that it is functioning properly. 44thly, consider the use of energy-efficient appliances. Energy-efficient appliances can help to reduce energy consumption and lower utility bills. Look for appliances that are ENERGY STAR certified. 45thly, ensure that all electrical boxes are properly secured to the wall or ceiling. Loose electrical boxes can be a safety hazard. 46thly, consider the use of cable management systems to keep wiring organized and prevent it from becoming tangled or damaged. Cable management systems can include cable ties, cable trays, and wire duct. 47thly, ensure that all electrical work is performed by a qualified electrician. Electrical work can be dangerous and should only be performed by someone who is trained and experienced. 48thly, consider the use of tamper-evident seals on electrical panels and equipment. These seals can help to prevent unauthorized access to electrical equipment. 49thly, ensure that all electrical equipment is properly maintained. This includes checking for loose connections, damaged wiring, and other potential hazards. 50th, consider the use of whole house surge protectors. Whole house surge protectors can protect all of your electrical equipment from power surges.